At this point, you might be thinking that what I've been talking about with how to record the measurements is helping with the data tables, but we haven't gotten too far helping with the error analysis questions in that random error part of the lab. So I wanted to point out this error analysis worksheet. Both this and the error analysis pages are on the same page where you're finding this video. Those files are here. And so this is just a table to organize your thoughts on what sort of precision uncertainty you're seeing with each of these reported measurements. So here we have the measurement taken being 15 centimeters. And so what we are saying there is that that last digit, that 5, is uncertain. It's 15, but it could be 14 and it could be 16. So that's plus or minus 1 centimeters. The same thing with this. If you report your measurement as 17 centimeters, we are saying that that could be plus or minus 1 centimeter. All right, then we're going to calculate the area. And when I calculate this, my calculator tells me that I have 255 centimeters squared. But I am multiplying something that has 2 digits by something else that has 2 digits. And with multiplication, the number of digits is how we decide the significant digits of the answer. And so I have to round this down to something with just 2 significant digits. So I would be reporting 260 centimeters squared. There we go. So not 26, 260 centimeters squared. When I report that as my calculated area, this has 2 significant digits. So the 6 here is the last significant digit. That's where the uncertainty is. This 6 could be a 5. It could be a 7. So that's the digit that's uncertain. So the error that I'm implying there is that it could be plus or minus 10 centimeters squared in the area. That's the error that's implied for the reported area, which is correctly using the significant digit rules. Going to the more precise ruler, the ruler that has lines every centimeter. So it has a line at 14 and it has a line at 15. So you don't have to estimate 15 anymore. Now you can see that it's between 14 and 15 and you've estimated that it's 14.8. It could be 14.9, it could be 14.7. So you're implying that it's plus or minus 0.1 centimeters. And the same thing here. Now we'll go ahead and calculate that. 14.8 times 17.2. My calculator tells me that it is 254.56 centimeters squared. So that is 5 significant digits. I should not be using all 5 of those significant digits though, because I multiplied something with 3 by something else with 3. And so multiplication rules tell me that I should only keep 3. So I'm going to go ahead and say this is 255 centimeters squared. When I report 255 centimeters squared as my calculated area, I'm saying that this 5 is uncertain. It could be a 6, it could be a 4. So this area that I'm reporting is plus or minus, I should put a plus or minus up here, plus or minus 1 centimeters squared. Then with a more precise ruler, one that has lines for 14.8 and 14.9, we no longer have to estimate that 8. We can see the line for the 8. However, we don't have a line for this 2. We just estimated the 2 because it was between 14.8 and 14.9. So we were able to read this ruler plus or minus 0.01 centimeter. And the same thing for the width. We could read that plus or minus 0.01 centimeters. Then when we multiply that. 14.82 times 17.19. Oh, my calculator is giving me a whole bunch of digits now. 254.7558. So my calculator gave me 7 significant digits. That's more than I can use. Again, we multiplied something with 4 by something with 4. So we're going to go ahead and keep 4. We will keep 254.8 centimeters squared, meaning that this 0.8 is where our uncertainty is. The 8 is uncertain, and so that means a variation of 0.1 centimeters squared. It could be 254.7, it could be 254.9. So this is plus or minus 0.1 centimeter squared. All right, so these questions over here, does the area found for trial 3 fall inside the range of the area found for trial 1? So I think the problem here is students don't understand what that means. What's the range of the area found for trial 1? So here is trial 1, and we are saying that it's 260 plus or minus 10 centimeters squared. So the range for that, if it's 260 plus or minus 10, the range is between 250 and 270 centimeters squared. So that is the range. And now we have the area found in trial 3. The area found in trial 3 was 254.8. So the area found in trial 3 was 254.8 centimeters squared. Does that value fall into this range? And yes, it does. 254.8 is definitely in between 250 and 270. So that is what those questions mean. When you do your lab report, you can go through a similar exercise like this with your values for each of your lengths and widths. See what range you mean. When you get the area and you round it to the correct significant digits, what range does that imply? And then you can answer these questions. Figure out what's the area found in trial 3, what's the range of the area found for trial 1, and does that value fall inside the other one? It should be close. Sometimes when you round things, you don't actually get it to fall within the range. So if that happens, you can take a look and double check your numbers, but it might not happen. In this over here, this table over here, we have the same paper, but we have one where instead of this width, which is pretty close to 17 centimeters, when somebody was eyeballing that width, instead of 17, they thought that it looked like 18, which turns out to be a little bit off. So you can go through this table yourself and see if the answers to these questions are the same with this data as they were with the data up top. And I do have also a filled in worksheet like this on this page, the same page that has this video, and it has the blank worksheet. It also has a filled in worksheet if you want to check your answers. But this video is already pretty long, so I think I will leave the rest of it for you to work on.